Lesson 7.2 is Theoretical and Experimental Probability. From your notes, you should see that probability measures the likelihood of an event or outcome. All the possible outcomes make up the sample space. So for outcomes that have the same likelihood of occurring or equally likely outcomes, the probability of an event E is defined as follows. The probability of E, number of favorable outcomes, over the number of outcomes in the sample space. So one thing that you need to remember is the probability of E has to be between 0 and 1 inclusive. So the probability of E, for example, can't be 1.5 or -2 or anything like that. It has to be between 0 and 1. Okay? Probability has to be out of 100%. So if we have two 1 through 6 number cubes that are rolled, if the number of cubes on each cube are equally likely, what is the probability that the sum is 8? First thing that's happened here is that we found the sample space. The sample space, if you roll two number cubes, there are 36. You could get a 6 and a 1. You could get a 6 and a 2. You could get a 6 and a 3, and so on. So there are 36 different outcomes. And if you notice what we've got here, the greatest possible sum would be 12, obviously. Rows show the outcomes of the second number cube. Column shows the outcomes of the first number cubes. So keep this sample space in mind as we answer some of these following questions. It says find the outcomes with the sum of 8. That happens several different ways. The sum of 8 can be 6 and 2, 5 and 3, 4 and 4, 3 and 5, 2 and 6. So there are 5 different ways that you could have a sum of 8 out of 36. So there are 5 out of 36, or 5/36 possible favorable outcomes. So the probability the sum is 8 is 5 out of 36. So the questions say two number cubes are rolled. If all number cubes are equally likely, what is the probability of each event? The sum is 3. So you want to look at the sample space. We're going to get rid of the sum is 8 up here. And let's go through and find all the ways that the sum could be 3. It could be 2 and 1, or it could be 1 and 2. So where it says list the favorable outcomes, 1 and 2, 2 and 1. Find the probability. There are 2 out of 36, which is 1/18. Okay, the sum is 4. List the favorable outcomes. So again, we want to go up here and we want to find any way that I can add to be 4. And that occurs when I have 2 and 2, 1 and 3, or 3 and 1. So 2 and 2, 1 and 3, or 3 and 1. So the probability is 3 out of 36, or 1/12. And lastly, a sum of 9. Same process. We're going to come up to the chart and we're going to think of all the ways that we can find a sum of 9. And that would occur with 6 and 3, 5 and 4, 4 and 5, or 3 and 6. Doesn't matter the way you list them as long as you list them all. I suggest, like I did, that you highlight or circle or do something to make sure you find them all. So that's 4 out of 36, which is 1/9. So the probability that the sum is 9 is 1/9. Okay, you want to flip pages. And we're going to get to theoretical and experimental probability continued. It says to find the experimental probability of an event, conduct or observe an experiment for a large number of trials, then count the number of times the event A occurs. It's just what we did yesterday in class when we spun the spinner, and we did it 50 times a piece, and then we combined all the information onto one table to look at all the class's totals together. So the experimental probability is the number of times the event occurs over the number of trials. So the table shows the results of an experiment with a spinner. So someone did an experiment just like we did in class yesterday, and they discovered that they had 30 red, 25 yellow, 12 green, and 33 blue. Okay? That is a total of 100 trials. So if I want to find the probability of red, I look at the chart. There were 30 red out of 100. So the probability is 3/10 or 0.3. If I want to find the probability of a green or a blue, the probability of green is 12. The probability of blue is 33. That adds to be 45 out of the same 100 trials, which reduces to 9/20 or 0.45. The table shows the results of a spinner experiment. Use the table to find the experimental probability. Spinning a 3 occurred 8 times out of a total of 55 times. So spinning a 3 would be 8 out of 55. It doesn't reduce. You're more than welcome to change it to a decimal if you like. 8 divided by 55, which is 0.15. Or 15%. Okay, to spin an even number, that can happen 2 different ways. 2 is an even number, 4 is an even number. So you're going to do 10 plus 22 over 55, which is 32 over 55. A 1 or a 2 is going to be 15 and 10. So 15 plus 10 over 55 is 25 over 55, which reduces to 5/11. Okay, the number 7, spinning a number other than 2. There's actually 2 ways that you could do it. You could either add up the 15, 8, and 22, and with a chart this small, not a problem at all. Or you could say, okay, what if I had the probability of getting a 2, which is 10, and since we know that all probabilities add to be 1, you could take 1 minus 10 over 55, which is 55 over 55 minus 10/55, which is 45 over 55, which reduces to 9/11. Like I said, with a chart this small, adding up 15, 8, and 22 is probably just as easy. But if you had a bigger chart, using the complement would be a great way. Okay, geometric probability, last thing. Find the probability that a point chosen at random inside the larger circle shown here will also fall inside the smaller circle. First thing we want to do is we want to find the area of the large circle. So area of large circle equals pi r squared, so pi times 16. The area of the small circle is pi r squared, which is pi times 9. And so if I want to find the probability I would take the area of the small circle over the area of the large circle, and I could reduce the pies and just get 9/16. The homework for today will be a 7.2 worksheet. Make sure you read the directions and turn it into the sub before you leave.